Okay, good morning. Today we are covering Algebra 2, Lesson 5.3, Dividing Radicals. And you're going to be able to simplify a quotient of radicals by multiplying by the conjugate to clear the radicals. That's the important thing. We have to clear the radicals in the denominator. So you're going to be dividing by multiplying the conjugate to clear the radicals. And this supports IXL lesson M11. And remember to upload your notes to me. Be sure you put your header on it, as I've said before. Make it clear. And it's due by 11:59 p.m. Saturday. All right, so the first thing we're going to do is we're going to go ahead and try to simplify. But before we simplify, what I want to do is I want to go over the concept of what a conjugate does. When we simplified, well, in fact, let's do this. Let's simplify this fraction that I've got here. So this is square root of 9 divided by 50. So to simplify a fraction like this where the denominator is a monomial, which is 50 here, all you have to do is rationalize the denominator. In other words, you want to get it out of radical form. So let me show you what I mean by that. Let's just rewrite this as the square root of 9 divided by the square root of 50. Now we can't have a radical sign in the denominator. So we're going to want to rationalize that. And so the first thing we want to do is we want to go ahead and factor everything we can factor. So square root of 9 we know is 3. So we get rid of that radical real fast. The square root of 50, that factors into the square root of 25 times the square root of 2, right? And so it's that square root of 2 we want to get rid of. But we know that the square root of 25 is 5. So let's just rewrite this as 3 and then over 5 times the square root of 2. So this radical square root of 2, that's what we want to get rid of. So we want to rationalize. This is a monomial, and we can rationalize this monomial simply by multiplying. This is a monomial. We can rationalize it simply by multiplying this fraction times a number that's equivalent to 1, where the denominator and the numerator are the same as the radical in the denominator here. So the square root of 2 over the square root of 2. All right? So multiplying that out, you've got, at the end of the day, 3 square root of 2. 3 times the square root of 2 is 3 square root of 2. And then 5 times the square root of 2 times the square root of 2 is 5 times the square root of 4. And of course, the square root of 4 is 2. So we end up with 3 square root of 2 divided by 10. All right, so basically, these two fractions, so the square root of 9 over 50 and 3 square root of 2 over 10, they are both equivalent fractions. Both equivalent fractions. And if you don't believe me, you could go ahead and use a calculator. What did I do with my calculator? Here it is. So this is the square root of 9 over 50 over here. If I take my calculator and I type in, here's the square root sign, so I'm going to click the second button, square root, and then I'm going to type in the fraction in parentheses, 9, oops, first of all I got to turn the silly thing on, so let's turn it on. Okay, let's clear it. So again, I'm going to start out with clicking the second button and then clicking the x squared button, which is now the radical button. And then I put in parentheses, this fraction is really 9 divided by 50. So 9 divided by 50, and then close the parentheses. And then the whole thing is inside the parentheses for the radical sign. So I'm going to have second parentheses. I'll hit enter, and I get 0.42, approximately 0.42. So this is approximately 0.42. Now if I take this number over here and do the same thing, let's see what we get. So this is set up a little differently. So we've got to clear, well, we'll just start with a new one. So we're going to do 3 square root of 2. So we don't have to start with a radical. But I want to put this all in parentheses because I'm going to divide it by 10. So parentheses, 3, and then square root, so blue square root sign, and then 2, and then close the parentheses, and then I have to close that's the parentheses for the square root, so I have to close the parentheses for the whole numerator, and that's all divided by 10. And you'll notice I get exactly the same number, so approximately 0.42. So I'm not going to go through this each time, but you know, sometimes when I'm setting these up, I forget that I have to have multiple parentheses signs to make these things accurate. But you can take a look at the operation. I did this here, and just remember that these parentheses are grouping symbols, so we're trying to group things in the right place for them. And so with fractions, you usually group together everything that's in the numerator, and if there's a radical in it, that radical itself is a grouping symbol, and so on. Okay, and then of course you do the same thing in the denominator. All right, so let's go on now to the concept of a conjugate. And did we mention what the conjugate was? I don't think we did, so let's do that. So a conjugate, let's just go to the next page. So a conjugate has to do with binomials. So this is a binomial down here, right? It consists of two terms, 8 and the negative square root of 5. So I could take this, and if I were to try to multiply the numerator and the denominator times just the square root of 5 to rationalize it, what would happen is I would end up multiplying the square root of 5 to 8 over here, and I have 8 square root of 5, and then I would multiply that square root of 5 to the negative square root of 5. So I'd end up with the radical sign still in the denominator, and I don't want that. So I have to use a device called the conjugate. So if I've got 8 plus the square root of 5, right? I'm going to change it to its conjugate, and its conjugate is the same, but it includes this entire binomial that you see in the denominator. However, you switch the sign of the second term. So this makes it a conjugate. This is the conjugate of this number, okay? So we're going to multiply this whole fraction times a number equivalent to one that is composed of the conjugate. So I'm going to use, in this case, 8 minus the square root of 5. And I'm going to divide that by 8 minus the square root of 5. I should have put 8 plus the square root of 5 because this is 8 minus the square root of 5. So I did it the opposite the way I should have, but that's okay because I can change it. You know, this positive to negative can be negative to positive. So 8 plus the square root of 5 in this case. All right, so you're going to multiply these together. So this is going to become negative 3 times 8 plus the square root of 5. And down here it's going to be 8 minus the square root of 5 in parentheses times 8 plus the square root of 5 in parentheses. Now we distribute. So negative 3 times 8 and negative 3 times the square root of 5. Let's see what that comes up to. And then down here at the bottom, this is going to be 8 times the square root of 5, negative 5 times the square root of 8, and then negative 5 times positive 5. All right, so negative 3 times 8 is going to be negative 24, right? 3 times 8 is going to be negative 24. And so negative 24, and then negative 3 times the square root of 5 is just that, negative 3 square root of 5. Right? And then here we FOIL it. So 8 times 8 is 64. 8 times the square root of 5 is positive 8 square root of 5. 8 times negative square root of 5 is negative 8 square root of 5. And negative square root of 5 times positive square root of 5 is negative square root of 25. All right, so we'll rewrite this as negative 24 minus 3 square root of 5. Nothing to do in the numerator at the moment. And then down in the denominator here, you'll notice that you've got positive 8 square root of 5 and negative 8 square root of 5. Those cancel, okay? And negative square root of 25 is really negative 5 because square root of 25 is 5. So I have 64 minus 5 in the denominator. And of course, that simplifies to negative 24 minus 3 square root of 5, right, divided by 59. And that's your answer, okay? Now, just so you know, if you were to, take the original fraction, and if you were to take your calculator and go ahead and do the operations here, you would end up with approximately 0.52. And if you did it over here on the far right, you would end up with the same thing. So the two fractions are equivalent. Okay, I'm not going to go through the math again on that because it takes a lot of time to do that with these. But you saw it the first time and you saw it worked, and it's pretty simple. Okay, let's go to the next one then. So this is negative 8 times 9 plus the square root of 5. The conjugate for 9 plus the square root of 5 is 9 minus the square root of 5. So 9 minus the square root of 5 in the numerator and 9 minus the square root of 5 in the denominator. Now we go ahead and we multiply these together. So I've got negative 8 times 9 minus the square root of 5 divided by 9 plus the square root of 5 in parentheses times 9 minus the square root of 5. Okay. So let's distribute now. Negative 8 times the 9, negative 8 times the negative square root of 5, and then I've got 9 times 9, and I've got square root of 5 times negative square root of 5, and then positive 5 times the square root of 9, and positive square root of 5 times negative square root of 5. Negative 8 times 9 is negative 72. Negative 8 times the negative square root of 5 is positive 8 square root of 5. 9 times 9 in the denominator is 81. 9 times the negative square root of 5 is negative 9 square root of 5. Positive 9 times square root of 5 is positive 9 square root of 5. Positive square root of 5 and negative square root of 5 is negative square root of 25. So let's bring the numerator over. Negative 72 plus 8 square root of 5 divided by, all right, so look at the quadrinomial, pardon me, I'm thinking geometry with quadrilaterals. So I've got a negative 9 square root of 5 and a positive 9 square root of 5 that cancel. And square root of 25 is 5, so this, because there's a negative sign in front of it, it is negative 5. So that rewrites as 81 minus 5. And that simplifies to negative 72 plus 8 square root of 5 divided by 76. All right, now you can divide, if you'll notice this is 72 here, and this 8 here, and this 76 here. They're all even numbers. They all can be divided by 4. So I can divide out of 4 out of all these. And so when I do that, here's what happens. So 72 divided by 4. So here's 72 divided by 4. Oops, I got to turn it on. So again, 72 divided by 4. Make sure that was what I wanted. Yep, nobody know it's negative. So negative 72 divided by 4 is negative 18. So this becomes negative 18. So I'm going to write it as up here in the numerator as negative 18. And then I've got 8 times the square root of 5. Now I cannot divide square root of 5, and I cannot divide 4 out of the square root of 5, but I can divide it out of 8. So, 2 times 4 is 8. So this reduces to 2. So that negative 18 plus 2 square root of 5. Right? And then 76 divided by 4. That comes out to 19. So there's your answer. Okay? And again, you could, if you wanted to, there's your answer. You can compare these two fractions using your calculator, coming up with a decimal answer, and confirming that indeed these two fractions are equivalent. Okay? All right, 2 to go. So C is 4 times the negative square root of 3 minus the square root of 2. All right? And so the conjugate would be negative 3 plus the square root of 2. So I'm going to put that into the numerator and the denominator here to create my complex conjugate. So I got negative square root of 3 plus square root of 2 divided by negative square root of 3 plus the square root of 2. And remember, the numerator and the denominator are conjugates of this denominator because we want to get rid again of the radical, and this will do that. But since the numerator and the denominator are the same in the second fraction, we know that we are not changing the equivalency of the fraction itself. It's going to be the same proportion. All right, so let's see. Let's go ahead and multiply these together. So 4 times negative square root of 3 plus the square root of 2 divided by negative square root of 3 minus the square root of 2 times negative square root of 3 plus the square root of 2. All right, so we have to be very careful about our negatives and our positives and where they're at. Otherwise, we make mistakes. And I'm very prone to those, as you well know. So let's distribute 4 times negative square root of 3 and 4 times the square root of 2. And then we're going to FOIL the denominator. The denominator. So first, last, inner. and, well, first, last, inner, outer. Okay. So we got all the distributions set up. So 4 times negative square root of 3 is negative 4 square root of 3. And 4 times the square root of 2 is just positive 4 square root of 2. Did I do that right? Let me just make sure I did. Square root of 2. Yep, did it right. Okay, so now we're going to multiply negative square root of 3 times negative square root of 3. So that becomes positive square root of 9. So that's square root of 9, and it's positive. And then negative square root of 3 times the square root of 2. Now we can multiply those two together. Positive times the negative is negative. But when you're multiplying radicals, it doesn't matter if what's under the radical sign is different. You can multiply them together. So you get square root of, let's see, negative times positive. So that's negative square root of 6. And then this is negative square root of 3 times negative square root of 2. Negative times negative is positive square root of 6. And then, let's see, you've got negative negative square root of 2 times positive square root of 2. That's negative square root of 4. All right. So let's leave the numerator alone for the moment. Negative 4 square root of 3 plus 4 square root of 2, because we know we've got stuff we've got to simplify in the denominator. Square root of 9 here is really 3, right? These two cancel. Square root of 6 and negative square root of 6 cancel. And the negative square root of 4, isn't that just negative 2? So we end up with negative 1. So this becomes negative 4 square root of 3 plus 4 square root of 2. Okay? All right, so that's the answer there. And again, you can check it if you wish. All right, so then the last one we have is down here in D. Let's move this up. So D, the conjugate, let's be careful, let's not put an equal sign in here. Just turn this into a, we'll turn this into a sort of a zero. Just do this here. Okay, so this is going to be times the conjugate, and this is 3 plus 8 square root of 5, so it's going to be 3 minus 8 square root of 5 divided by 3 minus 8 square root of 5. All right? So let's multiply them together. So that equals, so that's the multiplication sign there. So 10 square root of 6 times 3 minus 8 square root of 5 divided by 3 plus 8 square root of 5 times 3 minus 8 square root of 5. So we're going to multiply this number times 3 and this number and that number times negative 8 square root of 5. We're going to do FOIL over here. Okay. All right, so 10 times 3 is 30. So we have 30 square root of 6. 10 times negative 8 is negative 80 times the square root of 5. And that's all divided by, let's see, 3 times 3 is 9. 3 times the square root of 5 is positive 3 square root of 5. Let's see. Oops. 3 times, that's negative. That's negative. So let's change that sign to negative. We'll let that dry for a little bit. And then 3 times positive 8 square root of 5 is positive 3 square root of 5. And then 8 square root of 5 times negative 8 square root of 5. 8 times 8 is 64, but it's positive times negative. It's negative 64. And then times the square root of 25. Okay, and if you remember, this is 9 minus 3 square root of 5. So, the negative square root of 5 and the positive square root of 5 cancel. And this square root of 5 is really 5, right? So this is really negative 64 times 5. That's what that is. And negative 64 times 5, let's see here, negative 64 times 5 is negative 320. So this becomes negative 320. All right? So let's move along. So this is 30 square root of 6 in the numerator minus 80 square root of 5 divided by, and this is negative 320. But we had this 9 over here. So we had the 9. Let's bring the 9 over. 9 minus 320. So 9 minus 320 is negative 311. And there's your answer. Okay. But can we, let's see, can we reduce in any way? Let's see, this is 6, this is 5. Oh, wait. Negative 80, this is square root of 30. 30. 10 squared, so negative 3 square root of 6, negative 80 square root of 30. So this is 30. Okay. All right. Let me see. Do we have everything here? Yeah, 30 square root of 9. And there's nothing we can reduce that I can see there. 30 square root of 6 minus 80 square root of 30 divided by negative 3, and it's 311. I dropped the 1. So that's your answer. Final answer, and we're set. Okay, so that's it. We've got it taken care of. We'll go ahead and upload this, and have a good day.